like a page back from where we were because we were doing the 1-9 on Thursday, and I skipped this to make sure hopefully everybody got their graphing calculator over the weekend if they didn't already have one. Okay, so we're just going to do a little vocabulary. So this says a blank is a graph that relates two different sets of data, so like an X and a Y, by plotting the data as ordered pairs, and it's called a scatter plot. And I'm hoping you guys have done something like this before, but we're going to practice it again today. So a scatter plot, you can actually visually look at it and it can help you determine if there is some kind of relationship between the data. All the data we're going to work with today is going to kind of look linear in nature when we work with it. And what we do once we have the scatter plot is see if we can approximate it. If the data is linear, we draw in what we call a trend line. So sometimes they'll call that a line of best fit or best fit line, depending on what textbook you're looking at. And basically it's a line that's going to approximate the data. We hopefully have done this before. If not, we're going to do this by hand today. What we're going to add into the mix is we're going to have the calculator help us with it. And that's going to be this next term. So it's called linear for like line, and then regression. Linear regression. It's the calculator's version of taking the data and writing the equation of the line. And I'm going to tell you up front, these are not the nicest of numbers when you do this. Sometimes I'm going to tell you we're just going to round to the nearest hundredth, but this is the calculator taking all the data and then creating a line that goes through it. All right, now this will be maybe totally new to you, so I'm going to do a little bit of a definition below this here too. But it says the blank, and in that blank I'm going to write correlation coefficient. The correlation coefficient. It's going to be a number, and it's somewhere between -1 and 1. And basically what it does is it tells you how good your linear regression or your trend line is for the data value. Now, we're not going to calculate this by hand, but I want to have you do something on the calculator for me real quick. The correlation coefficient is represented with the lowercase r. So I'm going to have you guys, because most of the calculators are not defaulted to show this to you, so we're just going to do one thing, and it's not a big deal, and once you turn it on, we don't need to do anything else. Okay, so I'm going to have you hit a couple buttons here, but I want to write them out so you guys can see. So I'm going to have you hit the second key, which is in the top, like kind of almost the left corner, but right underneath the y equals. So hit second, and then the 0 key. And the second function on that is the catalog, and it should take you to this big, long menu. This is literally everything in the calculator. So second, 0. Okay, now on the left side, it is the 5th button down. I want you to find, it'll look like X with a -1 exponent. If you look at it, this is because I'm in this catalog, it's going to use the letter, which is the letter D that goes with that button. So I just hit that X to the -1 button. It's right under the math key. It takes you down to the letter D's. So what you're looking for is you're looking for diagnostic on. And make sure you go to the on because there's a diagnostic off right above it. So you want diagnostic on, and you want your little like arrow or something right next to that. And all you're going to do is you're just going to hit enter 2 times. And it should take you back to the main screen, and then it'll say diagnostic on, and then it'll say done. This will just allow the R value to pop up. All right, is anybody not seeing that? Have any questions? Okay, we'll take care of these in a second. Now, what is the correlation coefficient in terms of a graph? So I'm going to draw you a couple pictures here. So there's many different ways, and you can see more examples than what I have here, but a strong positive correlation. I'm just going to kind of like draw a little scatter plot. Just basically the dots would be pretty tight together, and they would really look like a line. and I'm just drawing it with kind of like a positive slope there. Now, the closer the R value is to 1 or -1, bless you, the more, bless you, the better the correlation between the graph and the actual data that you have. So strong positive, I'm going to write, and there's different definitions of that, but between like 0.8 and 1 would be a strong positive correlation. And when I say positive, it just means that it would have a positive slope. Okay, you can have a strong negative correlation. So I'm going to kind of try to draw like a mirror image of this just with like a negative slope. So again, like your data on your scatter plot would be pretty tight together, and it would form what you could tell would be a line. In that case, the R value is going to be between about -1 and 0.8. There's different arguments for those values. So between those, that's considered a strong negative. Sorry, I should have a little negative in front of the 0.8 there. But it's going to just mean the R value being negative just means it has a negative slope. The R value being positive just means the line has a positive slope. Okay, so kind of on the same thing, like a weak positive correlation. So here you're going to have dots that are, you know, that you could still argue that you could draw a line through these, but they're maybe just not as tight together. And you would see that it would kind of trend to be a positive slope. And a weaker, maybe not the greatest, maybe a line is not the greatest estimation, but you could still make an argument. That's going to go somewhere probably between about 0.3 up to, you know, maybe the 0.8, like just below the 0.8. But anything in there is considered a little bit weaker. This is a really good model for the data. This is a little bit weaker. Same thing, if I have a weak negative, kind of, it's still, you could draw like a line with a negative slope through it and it would be decent, but the data is going to be more spread out. And that can be an R value anywhere between -0.8 and -0.3. And then basically no correlation would just be like random dots all over the place. You would tell me like I wouldn't even draw a line through this. It wouldn't make sense. Just like dots all over is basically no correlation. Now the R value there could be anything between like a -0.3 and a +0.3. So like if you had an R value that was 0, that would be absolutely no correlation, but it could fall anywhere kind of in that range. It just kind of depends on which textbook that you look at. But in general, if you have 0.8 or higher, that's a really good model, or if you have 0.8 or lower down to -1, that's a really good model. And all of those should be what we see today. We're not going to have any weird values that are not lines. They're going to be lines today. So what we're going to do is we're going to do this first by hand. So here's my lovely table, and this says calories and fat in a fast food meal. So X is going to be the fat here and Y is going to be the calories. So we're literally just going to come over here and do our best to plot these as points. So the fat and the calories correspond to each other in the same point. So like I have 6 grams of fat for 276 calories. So I'm just going to come over and we're just going to spend a couple seconds. Just plot these points. Your X-axis is going to be the fat, and sorry, the Y-axis is going to be the calories. You don't have to have a label on that, but let me just put it there. The X-axis goes by 5s. The Y-axis goes by 100s. So just do your best to kind of estimate, and we're going to plot these points. It does not have to be perfect. We're just trying to kind of draw a trend line is what we're doing here. So just for each one of these, just kind of do like a little bit of a guesstimate where you think the points should fall. You don't have like a ton of data here, but just kind of do your best to estimate. You don't have to label the points or anything like that. Anybody done this like in Algebra 1 or maybe even in middle school or something? Do you know what you do to draw a trend line through that data? Because I could argue, right, this is the shape of a line. Like, how do I draw it?
You draw a straight line while trying to balance the equal amount of points above and below it.
Perfect. Perfect description. Okay, so that's kind of why I gave you guys these lovely little rulers, if you want to use it. So just like Rudy said, like half above, half below, however you want to do it. And our lines all for this might be just slightly different, and that's okay. So however you want to do it. I'm just going to sketch something there. Just approximation of the data. We could argue that that goes in a linear direction and those are all kind of around that same line. If I wanted to write the equation of that line, how would I go about doing that? Bless you. I know we kind of threw absolute values in the mix there. Do you guys remember how to write the equation of a line though? If we have a picture of a line, like what would I need to write an equation of a line? What's maybe the first thing I would want to figure out? Slope, for sure. Okay. So, and you guys, you don't have to use points that were in the table, right? Actually, the way I drew mine, none of mine go through. So what I would look for, try and find yourself some, like maybe an easy point, or if you went through one of your values, mine looks like right through the point here, and do I have another decent one? This one goes right through here. I'm just going to pick 2 points. They can be part of the data set or they could just be points on your line. I'm just grabbing 2 nice points here. I have the point, let's see, 5, 200, and I have the point 35, 600, just on the trend line that I drew. So just pick 2 points. So we could have a little bit different equations here. That would be okay. If you want to use my points, you can, or if you want to use your own, that's fine too. They might just be a little bit different depending on how we drew them. And any of these formulas I'm going to use today, we will give you guys these for tests or quizzes. So if you need it, you're going to do y2 minus y1. I don't know why I just wrote another y. x2 minus x1 for your slope. So take y coordinate in one point and subtract the y coordinate in the other point. Doesn't matter the order you do it in. I'm just going to do the second one I wrote down and the first one I wrote down. And then you do the same thing with the x's. Just make sure the coordinates that are in the same point should be stacked on top of each other. And I don't know, I just wrote a comma. I'm messing up all over the place here. So let's see. Mine, I've got 400 over 30. All right, that is not the nicest slope in the world. So I'm just going to use, I tell you what, we're going to round all the stuff on the linear regression to the nearest hundredth today. So I'm just going to do that with my slope. So I'm going to do 40 divided by 3 there. So I'm going to write my slope in as 13.33. It's 13.3 repeating, but I'm just going to do 2 decimal places to make it look more like the linear regression. Okay, once you're there, completely up to you. I usually use point slope, which is y minus y1 slope times x minus x1. You'd fill in your slope, and then you'd fill in your x and y coordinates. So let me just I'll just use the first point. It doesn't matter which one you use. I'm going to use the one that I wrote down, 5, 200. So I'm going to do y minus 200. My slope, I just rounded it to 2 decimal places. That's what we're going to do with the linear regression when we do it on the calculator in a second. And then x minus the x coordinate of the point. All right, so 2 steps to get it into slope-intercept form. We'll do a little distributive property. And I'm going to take that 13.33 times the negative 5. So we're going to get minus 66.65. And I'm going to add 200 to that to get it away from the y. All right, so my trend line, And yours, if yours is a little bit different, that's totally, totally fine. I'm going to get 13.33x, and then I'm getting, for mine, plus 133.35. Okay, now what we're going to do is we're going to see how good of a model this is by comparing it to what we're going to get on the graphing calculator. So I'm just going to grab, if you just want, because there's not a lot of space on the notes, just to write this down. That's why I gave you guys this other lovely little packet to write some information down. So what we're going to do today, actually these directions can be used for a bunch of different regression models, but specifically today we are going to do a linear regression. This just means like a linear equation that goes through your data. Calculator performs the process for you. I literally just kind of stole a picture of the calculator from the internet. The button that you're going to want to use to do this today is right kind of by your arrow keys, and you're going to look for a button that says Stat. So here's just my main screen. I'm just going to pull this down so you guys can see the data, because we're going to enter that into the calculator, bless you, in 1 second. So first thing I want you to do is you want to hit that Stat button, and it's right kind of in the middle, like third button down in the middle column, it just says Stat. And from that screen, actually this, you don't have to do anything here. What you actually want, I'm going to write it down. It says Edit, and that has a 1 that's highlighted next to it. All you're going to do here is hit Enter. Okay, now if you have data in here, I'm going to show you how to do this real quick, but we'll go back through this again so you can practice, because you might not have data in here. If you have data in here, which I do not use the delete key. Do not use the delete key. So what I'm going to have you do, I'm just going to use my arrow key, go to the top of the column if there's any numbers there, and so just arrow up to the top, and basically you have these L1, L2, L3. You want that highlighted. You're just going to hit clear, and it's not going to look like it's doing anything. Hit the clear button. It's right under the down arrow key. Hit clear. And what it does, you'll see this line down here will disappear, but just hit clear and then hit enter, and it should get rid of any data if you have some in your column. And then I'm just doing the same thing, just arrow up to the top. That's L1 stands for list 1. I'm just going to hit clear, I'm going to hit enter, and now I don't have any data. And we'll practice this again because we'll do an example together in a second. And then I want to show you just another little thing too. Does anybody's not start with list 1? Like, does your column say something different here? I'm just going to show everybody this. Okay, let's say, don't use your delete key here, just please don't. But let's say I accidentally deleted the whole column out, right? And it starts with list 2. If you do something like that on accident, I'm just going to show you just 2 quick steps to reset this. Hit Stat, and then what you want on that screen is the number 5 that says Set Up Editor. You hit Enter 2 times, and that'll reset that whole screen. So if you mess something up or you delete something you don't want to do, Stat number 5 says Set Up Editor. Just hit Enter twice. It'll take you to this screen, but it'll reset that. So now I'm just going to hit my Stat key again, my Edit, I'm going to hit Enter, and you can see that that restored that column that I deleted. So if you do that on accident, no big deal. Now, L1 stands for list 1, and that is where we're going to type our X values. And the second column says L2, which just stands for list 2, and that is where you want to put your Y values. So hopefully you guys can, I've got them at the top of the screen here. So in the first column, I'm just going to type the X values. So I'm going to type the number 6, and then you have to hit enter in between each of these. So like 6, enter, 7, enter, and then I'm just going to type on down, just type these X values across the top of that table. Enter after each one, even the last one that you put in. So when you put in the 36, make sure you hit enter. And then I'm just using the arrow keys. I'm going to arrow right over to the next column and just put the corresponding Y value, which are your calories here, right next to the X value it goes with. And same thing, you have to hit enter after each one. And then I always just take a second and I just look at my table maybe one more time for my worksheet or whatever I'm working with. And I just look down here and make sure I didn't mistype any digits or anything like that. And you have to make sure you have the same number of values in the list 1 that you do in list 2. Like if you forget one, it won't do it. So the columns have to match. Is anybody having a question? Is yours looking weird? I'll come look at it. Give me 1 second. Let me just tell you guys the rest of the directions here. It's real quick. Okay, so after you get these in, you're going to hit back, and you're going to take that stat button again. All right, you can just do it right from that screen, just stat. You're going to arrow across the top to the menu that says calc, just using the arrow key. Stands for calculate. There's a whole bunch of stuff that this menu will do. We just want the linear regression. We want it to write the equation of the line for us. What you want is number 4. It says LINREG, and then it says AX plus B. And I know you guys are used to MX plus B. For some reason, the calculator uses an A here for the slope. So you can type the number 4, or you can arrow down to it, either way. And I'm just going to write down, you're going to keep hitting enter. And it depends on your calculator. It might take you to the screen, it might not. But just keep hitting enter until it gives you the linear model. Is anybody's not? Okay. Okay, is anybody else seeing something that wasn't for? Okay, is anybody else seeing it? Does anybody's not display that R? We just maybe forgot to do the diagnostic on. If you guys want to go ahead and write down that equation, just round the slope to the nearest 100. Okay. All right, sorry about that. Now, we have our regression model. I'm going to grab my calculator here real quick so I can read it. So I'm just going to round. Actually, it asks us about our correlation values. So that's at the very bottom. Hopefully you have this the R. and I'm just going to go 2 decimal places, it's 0.97. The closer that is to 1 or -1, the more perfect the trend line is. Like a perfect 1 would go through every single point. This is a super strong correlation. So this means this is a really good estimate. We could use this to make predictions and things like this. This is strong, and I'm saying positive only because the slope is positive. That's the reason. If it can also be strong negative, that would just be like a negative 0.97 or something like that is your R value, but our slope is positive here. And then I'm just going to write this down. So here's my trend line. They have for their slope, I'm going to go like 13.61 times x, and then their y-intercept, they have the b, it's positive, so I'm going to put plus 150.87 to the nearest 2 decimal places there. And you guys can kind of compare that to what we got on the trend line, and maybe yours is even a little bit different than mine. And we're going to use our 2 equations to make a prediction and kind of see, like, how did our model by hand compare to the calculators. The calculators takes into account every single data value that you have, whereas ours, we're just grabbing 2 points and writing the equation of that line. So we're going to compare these real quick. So if I say to you, use your equations to predict the number of calories when we have 14 grams of fat, what would you do to make that prediction? Does anybody know? If we've got those 2 equations, like, how would I make that prediction? What do you think? Exactly. This is lining up your x values were the grams of fat, so you're just going to plug that in for x. Okay, so for the one, if you wrote a different trend line than I did, yours might be just a slight bit different. But I'm literally just going to plug in 14 to the equation that we wrote down a couple minutes ago before we were working on the calculator, and I'm just going to figure that out, and I'm going to, oh, actually, sorry, forgive, I was going to show you guys this. If you have the linear regression on the screen, you can get rid of it. If you want to, just hit the clear button right under the down arrow key, and it'll get rid of it and take it back to a normal screen. So I'm going to plug in 14 to my lovely regression line that we did by hand, and I'm getting an estimate of about 319.97. That would be calories. And then I'm just going to compare that to the data model that the calculator gave us. So they had a slope of 13.61. I'm going to plug in the same x value. They had a little bit different slope and a little bit different y-intercept, but we're just going to compare the 2. Just plugging this in, and I'm getting 341.41. And you guys can see the calculator model should be a pretty good prediction because we can see the correlation coefficient. I am not having you guys calculate that by hand. That's something you will do if you do AP stats. But in comparison, that model should be more accurate. So the 341.41 that the calculator gives us as an estimate, that should be more accurate. This is telling me my trend line was pretty good. I mean, it's not so far off, but it's not maybe as close as it could be. So the calculator model will be the better prediction unless you have a really good trend line and you picked your points really well. Okay, we're just going to try this one more time just so I can make sure everybody's comfortable with the calculator button. So on the back here, I just have a little different data set, and this says the data is going to represent the time it takes to travel a certain number of miles. So x is going to be the number of miles that are traveled, and y is going to be the time that this person took to make that happen. So when you get over to the graph, the x-axis goes by 2.5. and the y-axis goes by 10. So again, some of these might be nice x values, and some of them are just going to have to kind of estimate. And just do the best that you can to kind of make a scatter plot here, because that's part of our goal, that we can do this by hand, and then we'll compare it to the calculator model and see how well we did. So just take a second or two and just do the best you can. Make a little scatter plot of this data. There's not too many data points. And to draw that trend line by hand, remember, you can use you don't have to use a ruler, but I think it makes it a little bit easier to do. Just kind of, bless you, like half above, half below. And again, if you got to write the equation of that line, you need 2 points. They do not have to be data points, but you can use those, or just any point that goes right through a corner if you want to make a better line for yourself. Oh, my battery is running low on my computer, so I'm going to go get my charger real quick. But take a couple points, and we're going to write the equation of y. And everybody's trend line would be a little bit different because we would probably pick different points. So whatever points you want to pick. I'm going to use, one of the points I went through was the 25, 120. Oh, let me find another point. My graph also goes, it's not one of the data values, but my graph also goes to the point 1570. So whatever points you want to pick, those are the two I'm going to use. And again, you do y-coordinate in one point minus the y-coordinate in the other point on the top to get your slope. Then you're going to do x-coordinate in the point that you started with minus the x-coordinate in the second point that you use. Mine, let's see here, I'm going to get negative 50 over negative 10. The two negatives are going to cancel. So actually, mine, I just had a slope of 5. So that didn't happen in the first question, but I got a nice number. All right, once you got your slope, pick one of the points. It doesn't matter which one. I'm going to pick the second point, and I'm going to do y minus that y-coordinate equals my slope, which we had to figure out, so we might have different values, and that's totally fine. And just 2 steps to get it in slope-intercept form. So we're going to multiply. For me, I'm multiplying by my slope of 5, so I'm going to get 5x minus 75 for mine. And then I'm going to add 70 to get y by itself. So for mine, I got 5x, let's see, minus 5. That's my trend line. And then I'm going to have the calculator do it for me and see if we can compare and see if we got a pretty good estimate of this data. Now, once you guys are ready, I'm going to go through this step by step one more time with you just to make sure. So once you're ready, we're going to hit the stat button, which is right in the middle, the third row or third column, third button down. And from there, you want to edit. So you're just going to hit enter from that screen. And now everybody should have data. So I'm going to repeat this for you one more time. To get rid of this, do not use the delete key. Okay, just don't. What you want to do, just use your arrow key, go up to the top of the column so that either L1 or L2 is highlighted in black there. So I have list 2 for mine. Hit clear, which is right under the down arrow, and then it's not going to look like it did anything. Hit enter, and then it'll wipe that whole column out. And I'm just using the arrow keys. I'm going to arrow over, go up to list 1. So that list 1 has got like a black background. Hit clear, hit enter, and it should totally get rid of all the data. If you accidentally deleted a column, there's no big deal. Just hit stat, and then number 5 will reset. Setup editor will reset that menu. You just have to hit enter twice, and then can go back into that menu, and it should be restored. All right, now remember, list 1 is for your x values, and you have to type enter in between each. And once you got those, then just arrow over to the second column, list 2, and we're going to type the corresponding y value next to its x value. And you get, again, you have to hit enter in between each. And just take 2 seconds and spot check and make sure your x and y values match up with each other like they do in the table that you guys have. That hard part there is just making sure you enter all the data and you enter it accurately. And if you do make a mistake, you could just arrow up to it and you can type right over it. Once you have the data in, we're just going to hit stat. We're going to arrow over now because we put the data into the calculate menu, and you want number 4, which is going to say lin-reg, which stands for linear regression, and we're just going to keep hitting enter until the linear regression shows up for you. It should also display your R value at the bottom of the screen. So I'm going to jot that down right here. Now this R value, 0.99, what does that tell you about the trend line that it made for your data in the calculator? If you get 0.99 as your correlation coefficient, it's like super, super good. Super good. It's almost 1, right? So it's almost perfect. So this is strong positive, but literally almost perfect for in terms of a prediction or something like that. Now, when you guys have this, these always have like really garbagey decimals unless it's some fluke thing. So I'm just going to go 2 decimal places. So y equals, it's ax plus b. So the a they give you there is your slope. So let's say about like 4.67. And then I'd have an x next to that. And then the b value, the y-intercept, is about 1.73. Which, forgive, I should have written my regression maybe up here. But then what I'm going to do is we're going to predict, using our 2 models, which one we think gives us a more accurate read on the time it would take to travel 32 miles on the bike. So all that's telling you, we're going to plug in 32 for x. So for the equation that I wrote, it would just be 5 times 32 minus 5, just using my trend line. So I'm just grabbing my calculator. If you just want to hit clear, it'll get rid of that regression. Do 5 times 32 minus 5 for mine. So about 155 minutes is my prediction. Now for the calculator's prediction, we're just going to plug it into the linear regression model. So their equation was 4.67. I'm going to plug in the 32 and then plus that 1.73. So we're just plugging it in. And you can see here on this one, we're a lot closer, but a little bit more than the model that the calculator gave us, but that's a pretty good comparison. That lets me know that trend line that I drew was pretty darn good on this one, and the calculator is going to be more accurate for you. Is anybody having a question?